Again we will see about K-map. Okay. So suppose any function y, if it is a function of 4 variables a, b, c, d, and if it is written like this, summation of n 0, 3, 5, 7, 9, 11, 12, 14 and 15. Okay. So how we can reduce this function by using K-map? So first of all we have to plot this function in K-map. This is SOP representation. This is SOP function. Okay. So you first of all you have to plot a 4 variable K-map. Okay. So for a 4 variable K-map, the number of cells are 16. 2 to the power 4, it is equal to 16. So it is 0, 0, 0, 1, 1, 1 and then 1, 0. Similarly for CD it is 0, 0, 0, 1, 1, 1 and then 1, 0. Okay. And so you have to put at this place it is 1, because for 0, 0, 0, 0, M0 it is 1. Then again for M3 it is 1. For M5, M5 means 1, 0, 1, it is 1. Then M7 again it is 1. M9, M9 means it is 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, this is 1. 10, 11, 11 is again 1. 12 is 1. 14 and 15. 14 and 15 both are 1. So first of all you have to plot this function in a K-map. Okay? In this way you can plot it, and in the remaining cells you have to put 0. Okay? Then you have to combine either 2 adjacent one, or 2 to the power 2 adjacent one, or 2 to the power 3 adjacent one, or 2 to the power 4 adjacent one. Okay? So you can see you can combine these 4 ones. Okay? Then what you can combine? You can combine this one with this one. You can combine this one with this one, and this cannot be combined. Okay? So after combining these 4 one, the reduced term is how you can get it? You have to see which is common for all these ones. Okay? For all these 1 is not changing, means C and D is not changing. Okay? So you have to write for these 4 ones CD. Similarly for these 2 1, which variable is not changing? 0 is 1 is not changing. Similarly this 1 is not changing. So what you can write for this? It is A dash, B, and this is D. Okay? Then for this one and this one, after combining, what you can get? For this 2 1 is common, means A, B is common, and similarly D dash is common. So you can write A, B and D dash. Okay, and for this one, what you can write? You can write A dash, B dash, C dash, D dash. Is it clear to all of you? So you can write the reduced expression y, it is equal to A dash, B dash, C dash, D dash plus A dash, B, D plus A, B, D dash plus CD. So in this way, by using K-map, you can reduce any function. Now, since this is in SOP representation, now you know that SOP and POS both are complementary in nature. You can write for this in POS form, it is equal to 1, 2, 4, 6, 8, 10, 13, like this. Okay. So by using SOP, what you get after reduction? Y is equal to, you write, it is A dash, B dash, C dash, D dash plus A, B, D dash plus A dash, B, D plus C, D. So there are 4 terms after reduction by using SOP. So you can write this expression as in POS like this: pi of m 1, 2, 4, 6, 8, 10 and 13. Since both are complementary in nature, so you can write like this. So for this, how you can represent it in K-map? For this you have to see either you can write AB or A plus B, then you can write C plus D. Both are same. Here you can write 0 plus 0, 0 plus 1, 1 plus 1, 1 plus 0, 0 plus 0, 0 plus 1, 1 plus 1 and then 1 plus 0. Okay. Now at the place of 1, you have to put 0. At the place of 2, 2 means this cell. So you have to write 0. Similarly for 4, this is 0, 1, 2, 3, 4. 4, you have to put 0, 5, 6. At this place you have to put 0, 7, 8, 9, 10, 11, 12, 13. So you have to put 0 at the place of 1, 2, 4, 6, 8, 10 and 13. And in another remaining cells you have to write 1. Okay. Then you have to combine either 20 or 40 or 80 or 16 adjacent zeros. Okay. Now if the function is like this, y is equal to y, it is a function of A, B, C and D. If it is equal to summation of m 0 to 6 7 8 9 plus d 10 12. Then how you can plot this function in a K-map and how you can reduce this function. This D stands for don't care. Don't care. Okay. So don't care, you can represent it by x. X may be either 0 or it may be 1 depending upon the situation. You have to see. So how you can represent this in a 4 variable K map? Let's see. Suppose this is AB and this is CD. Okay. This is 0 0 0 1 1 1 and then 1 0. Similarly, this is 0 0 0 1 1 1 and then 1 0. Okay. So first of all, you have to plot the min terms. Min terms are at 0. So you have to write 1. Similarly, at the place of 2, 0 0 1 0, you have to put 1. Then at the place of 6, 0 1 2 3 4 5 6. At the place of 6, you have to put 1. Then at the place of 7, this is for 7 and 7 7. Okay. Then 8 and 9. So this is the place for M0, M2, M6, M7, M8 and 9. So at these cells you have to put 1 and don't care, you have to write at the place of 10. So this is 8, 9, 10 and then 11, then 12. Okay. So you can write D for don't care. Okay. Then you have to combine. You can combine this D with the adjacent one. And if the don't care is not combined, then in that case D will be equal to 0. If the don't care is combined with 1, then in that case D will be equal to 1. And if don't care is not combined with 1, in that case D will be equal to 0. So how you can combine it? See, you can combine these two ones. You can combine this one with this one. Similarly, you can combine this one with this don't care. You can combine this don't care with 1. Similarly, you can combine this one with this one, and you can combine this one with this one. Okay, so you have to write. So here you can see all the don't cares, means this D and this D. Here D will be equal to 1. But if D is not combined, if say D is at this place, if D is at this place and if this at this place 0 is there, then in that case D will not be combining with anyone. Then in that case D will be equal to 0. But here since D is combined with 1, here D is combined with 1, so in this case D is equal to 1. So what will be the reduced expression? See, if you are combining this one with this one, A dash B dash both are common, A dash B dash, and you can see this 0 is common. So you can write D dash. Okay. Then this one with this one, C D dash is common and A dash is common. So you can write A dash C D dash. And if you are combining this one with this one, then common term is A dash B, A dash B C, A dash B, and this one is C. Okay. Then for this D and 1, C dash D dash is common and here A is common. So you can write A dash C dash D dash. Okay. Then for these two one, what you can write? 1 0 is common. So A B dash, you can write 1 0 is common, and for this you can see C dash is common, 0 0 is common. So you can write C dash. Okay. Then for this D and for this one, how you can write? 1 0 is common to this one and this D also. So you can write A B dash, A B dash, and what? This 0 is common. So you can write D dash, A B dash D dash. So Y is equal to A B dash C dash plus A dash C dash D dash plus A dash B dash D dash plus A dash C D dash plus A dash B C plus A B dash D dash. It is Y is equal to A B dash C dash plus A dash C dash D dash plus 1 2 3 4 5 6. 6 terms are here. So in this way you can minimize the function, any SOP function in which don't care conditions are also involved. Okay. In this way you can combine it. Then you have to see for POS function with don't care. Suppose POS function, it is written like this: pi of n 0 1 3 5 7 9 11 12 13 dot d 2 14 15. If it is written like this, then how you can plot this in a 4 variable K map? It is, you can write A plus B, then C plus D. And write 0 plus 0, 0 plus 1, 1 plus 1, 1 plus 0. Okay. Then you have to write 0 plus 0, 0 plus 1, 1 plus 1, and then 1 plus 0. So here it is, max term is 0. So for M0, this is M0, M1, MT, M5, M7, M9, M11, M12, and then M13. This is D2, D14, and then D15. Okay. So you have to put 0 at M0, then 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. See, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So at these cells you have to put 0, and for D2, where is D2? This is D2. So you can write D14. This is D14, and this is D15, and in remaining cells you have to put 1. So you have to combine this D with adjacent 0. If this D is combined with adjacent 0, then in that case D will be equal to 1, and if it is not combined with any adjacent 0, then this D will be equal to 1. So how you can combine? See, this you can combine, then this you can combine, 1, 2, and this you can combine. Okay, so for this, how you can write down the reduced expression which is common for this 0, this 0, this 0, this 0, this 0, and this D is equal to 0, because this D is combined with 0, adjacent 0, 0, 0. So how you can write which is common for all this? Common term is this 1. This 1. 1 means D dash. Okay? And for these 4 K-map cells, which is common? Common is this A dash plus B dash. A dash plus B dash means 1 plus 1 is common to all these 4 cells. Okay? Similarly, for these 4 cells, which is common? Common is this A plus B, 0 plus 0. 0 plus 0 means A plus B is common to all these 4 cells. Okay? So you can write down the reduced expression y, it is equal to A plus B dot A dash plus B dash dot D dash. Okay? So in this way you can get the reduced expression by using K-map. You can reduce any POS expression or SOP expression by using K-map. If the expression contains don't care also, then also you can reduce it by using K-map. So you have seen how to reduce any POS expression by using K-map, how to reduce any SOP expression by using K-map. So, and also you have seen how to reduce the canonical POS and canonical SOP by using K-map. From the truth table also you can reduce it by using K-map. First of all, you have to plot the truth table in a K-map. Then only you can reduce it. Okay? So in this way you can reduce any function by using K-map.